When rainfall hits the Earth's surface, one of two things can happen. Water can run off the land, or often, with the help of sound land management practices, water can move into the soil to be an environmental positive rather than a negative. The soil itself has an influence on whether water runs off or moves into the soil. Here's a brief explanation of how and why soils transmit water at different rates, and why you should check a soil survey when you're concerned about runoff, flooding, leaching, or other environmental hazards. Water movement in the soil is strongly influenced by soil particle size, or texture, as well as structure and pore size. Soil texture is the relative amount of sand, silt, and clay-sized soil particles. Sand particles are the largest, silt is intermediate, and clay is the smallest. Water moves more quickly through the large open macropores found in sandy soils than the smaller pores of silt, or the much smaller flat-shaped micropores in dense clay soils. Soil structure also impacts water movement. Water moves more quickly downward in soils with granular structure than a soil with platy structure that forces a longer indirect path downward. Other structures include prismatic and subangular blocking. Water is nearly always moving in the soil, and it can be in any direction simultaneously. Gravity is the dominant force that moves water downward. Restricted soil layers of compacted soil or bedrock are among the reasons water moves laterally. Capillary action, the attraction of water into soil pores, can move water in any direction. Gravity is the primary water-moving force in saturated soils, while capillary actions are the primary forces in unsaturated soils. Capillary force is greatest in soils with small pores. Water moves more slowly through these soils. Well, that's a brief explanation of what a soil scientist calls saturated hydraulic conductivity. In simpler terms, the capacity of a soil to transmit water. Since downward-moving water carries nutrients and can carry contaminants into underlying groundwater, soil percolation rates are important in choosing sites for septic fields, landfills, and other waste burials, as well as underground storage tanks and other uses. The information is critical for planning soil drainage, irrigation, and tillage systems, as well as other crop management practices. Get the information you need on water movement rates and other soil properties from the soil survey of your area on the web at www.soils.usda.gov.